In the previous clips, we have implemented the main view model. In the main view model, we subscribe to the Open Friend Edit View event that is published from the Navigation View model. When we receive that event in the main view model, we create a new Friend Edit View model. On that Friend Edit View model, we call the load method to load the friend with the ID that we have received from the Open Friend Edit View event. The logic in the main view model is programmed against the iFriendEditViewModel interface. And now we need to focus on the implementation of that interface in the Friend Edit View model. We want to load the friend with a friend ID that we got from the main view model by using a friend data provider. So let's switch now to Visual Studio and let's implement the friend data provider and the Friend Edit View model. Okay, here I'm back in the Friend Storage application. I have already prepared the Friend Data Provider. So here I have an iFriend Data Provider interface and an implementation. Let's include these two files in my project. As you can see, the iFriend Data Provider interface has a method getFriendById where I can pass in a friend ID and I get the friend. It has also the methods saveFriend and deleteFriend. But for now, we just need the getFriendById method. When we look at the implementation, we see that this friend data provider has a func of iDataService as a constructor parameter. That func is stored in the DataService creator field. As you might remember, the iDataService interface is part of this data access project. We have here an implementation with the file DataService, and we have here the iDataService interface. Okay. Then when I scroll down in the data provider, you see here the getFriendById method that just creates the data service with this func, and on the data service it calls the getFriendById method. Then I have the two other methods to save a friend and to delete a friend. Okay, so far to my iFriend data provider implementation. As we have that interface now, we can use that data provider in the Friend Edit View model. But before we switch to that view model, I want to show you a test class that I've already prepared. Let me include that file as well into my test project. And as you can see, the class is called Friend Edit View Model Tests. In the constructor, I create a new mock for the iFriend data provider, and I store that mock in the data provider mock field. On my mock, I set up the getFriendById method for a friend ID which I have defined here as a constant integer with the random number 5. When that getFriendId method is called with this friend ID, a new friend is returned that has that ID and that has the first name Thomas. Then I create a new Friend Edit View model and I store that Friend Edit View model in the field View model. As you can see, I have a constructor parameter which is in this case an iFriend data provider. That constructor does not exist yet in the Friend Edit View model. So let's create it from here. Generate constructor. Okay. Now when I scroll down here, you can see two test methods in this class. The first one is called shouldLoadFriend. On the Friend Edit View model, I call the load method with the friend ID. After that load method, I assert that the friend property of my view model is not null. And I also assert that the friend has the ID that we have passed in to the load method. Finally, I verify on the iFriendDataProvider mock if the getFriendById method has been called with that specific friend ID. And I want to verify that it has been called exactly once. So this is the loading logic. Then I have another test here that is called shouldRaisePropertyChangedEvent for friend. As you can see, here I used the extension method that we have created in the previous clip. When the load method is called on my view model, I want to verify that the property changed event is fired for the friend property. So I store the result of this extension method in this fired variable, and I assert that the fired variable is true. Now when I run these tests in the Test Explorer, we will see that both tests are red. Okay, the two tests are failing. Now we can implement the logic in the friend-edit view model. We have two red tests for the friend-edit view model. Now let's implement that logic. So let's open up our friend-edit view model. Here we see the constructor and the parameter that we have added by using the Visual Studio refactoring tools. Let's rename that parameter to Data Provider. And let's also rename the field here to _Data Provider. Okay. Now when the load method is called of that friend-edit view model, we need to load the friend for this friend ID. So let's do this. We can load the friend by using the data provider's getFriendById method. So we just pass in the friend ID that we receive here as a parameter. After we have loaded the friend, we assign it to our friend property. But as you can see, the friend property has just a getter yet. So let's create a private setter here on that property, and let's store the value in a field that we call friend. And for sure, Visual Studio can generate that field for us. Here we have it. In the getter, we just return that friend. Alright, cool. So we have already the loading logic. Let's run the tests in the Test Explorer, and one test should be green. Yes, the shouldLoadFriend test is green. Now we also need to raise the property changed event when that friend property is set. The friend-edit view model inherits from viewModelBase, and that viewModelBase class implements the iNotifyPropertyChanged interface. As you can see, it has a method onPropertyChanged that we can use to raise the property changed event. So let's just call that method in the setter of our friend property. Alright, that's it. Now we can run the tests again, and all the tests should be green. Okay, cool. Now we are done with the implementation in the friend-edit view model to load a friend by ID. Now let's review what we have done, and let's run the friend storage application. So far we have implemented the logic in our view models to load a friend. When an item in the navigation view model is clicked, the Open friend-edit view event is published with the friend ID. The main view model subscribes to that event, and it creates a new friend-edit view model. On that friend-edit view model, it calls the load method with the friend ID. The friend-edit view model itself loads the friend by ID by using the friend data provider. We have tested everything with our unit tests, and now we can run the friend storage application. To do this, we need to adjust the AutoFact container, because the container does not yet know about several classes, we need to add the event aggregator, the friend edit view model, and the friend data provider. So let's add these classes now to the AutoFac container, and then let's run the friend storage application. Okay, here we are back in the friend storage solution. Now let's open up the Bootstrapper class where we create the AutoFac container. The Bootstrapper class has that bootstrap method that returns the container. And as you remember, here we map the concrete types to interfaces. Now the first thing I want to do, I want to register the event aggregator. So let's call the register type method on the container builder, and let's specify the event aggregator. And we need the Prism events namespace for that. I want to register the event aggregator as iEventAggregator. And I also want the event aggregator to be a single instance. Okay. Next I need to register the friend data provider, and I do this here where I have also the navigation data provider. So let's register here the type friend data provider as iFriend data provider. Okay, and we also register the friend edit view model, and we register that one as iFriend edit view model. Okay, so far so good. Our container looks great. Now let's see if we can run the application. Okay, the friend storage application pops up, and now I'm really curious what will happen when we click on a friend. So let's try it. And voila, you see a tab opens. When I click on another friend, that friend opens up in another tab. Now let's see what happens when I click again on Julia, and you see no other tab opens. Instead, the existing tab is used and selected. So that's quite cool. We have implemented all that logic without running the application for a single time. And this was possible with a test-driven approach. Now when you look at the application, there are still some things missing. We can't delete a friend, we can't save it, we can't close a tab, and we can't add a new friend. In the next modules, we will focus on these scenarios to finish the friend storage application. Now let's wrap up what we have done in this module. In this module, we tested and implemented the loading of friends in the friend storage application. As you might have noticed, there was no need to run the application to build and test the logic. As we have used test-driven development, and so we have written the unit tests upfront, we were sure that the logic is like we wanted the logic to be. We have also seen in this module that the unit tests allow you to focus on one part of your view model. You first write the test for that part, and then you can implement the logic. In the last clip, we have started the friend storage application, and you have seen that our logic worked. But you have also seen that friend storage lacks some features, like for example, save and delete. Let's build these features now in the next modules to finish the friend storage application.